Alright, welcome back. And in this video we'll start taking a look at methods on classes, because we can make instances. We can make instances and put data into them, but the class doesn't really do anything. We can assign anonymous functions to fields because we've implemented anonymous functions, which is beyond what the book has done so far, but we cannot put methods on instances. So that's what we're going to do now. And actually, as he writes, our helpful parser already passes methods declarations. As we see here under the class declaration, when we pass a class declaration, we get the name, then we look at a for left brace. Then we create this methods vector, which checks to see that it hasn't found a right brace and we haven't reached the end of the file. And then it just passes method after method and pushes them into this vector. And finally, we make this class statement. And if we look in the interpreter, we can see that we actually don't use the methods for anything. Also, in the value here, right now the class definition is just a name. Doesn't contain anything else. Now it's asking some interesting questions. Can we pull a method out like this, put it into a variable and then call it? And what about the other direction? Can we make a function and put it into a variable? We already allow this, so this is not a very interesting question for us. But just for the sake of symmetry, probably we should allow this one too. But let's see what he says. He will say the answer to both of these is yes, it does work. And I think that's good. It matches with what we have so far, so we don't have to do a big restructuring. All right, let's now get to resolving. And how do we do that? We have the class statement. Okay, he's actually looking at the function statement. Statement.methods. Anyway, what is this? It's probably up here. He also has visit class statement, so yes, it's definitely here. So we will say for method and methods, and not that, sorry, for method and methods, we want to let declaration equal function type. Very nice. This is less nice. Anyway, method. And let's now check a look at the function type. Doesn't have that yet, so we'll add it. And then we will call resolve function on the method and with this declaration. And it doesn't work because we had ignored the field. Let's see what it's now complaining about. I have no clue. Yeah, it's because it's not like this. It is like this. And resolve function is complaining about. Still don't know how to get the errors to show. It's because resolve function doesn't even take the declaration. Okay, so I looked up my own key bindings and now I can actually see what's wrong. So expected 1 argument, found 2. It's exactly what we analyzed our way to on our own. But let's jump to this resolve function. And here it's just getting, it has a hard-coded one, so let's add. Let's, oops, that's not what I wanted. I wanted to do this. So let's say type, let's say function type is a function type, and okay, here we're just matching on. So let's see what the, let me harpoon this so we have it. Let me see what the parser says. It is a what is it using kind for? Not really anything, it seems. It's a bit weird. But it means that these are function statements. So if we go back here, what's it now complaining about? Associated function defined here. Whatever. So now we cannot match on this, I guess. Well, it's fine. Let's delete that and put in function type. And then we can go up to here and put in function type, function. This one has a warning about an unused result. So I guess that's fine. Now I wonder if there's a way to see all warnings, but okay, good. So now presumably we can resolve those, at least do this. We added another type to the enum. Okay. Only difference is to pass in a new function type enum. That's going to be important when we resolve this expressions. For now, don't worry about it. The interesting stuff is in the interpreter. Let's go there. So again, he has a hash map. Let me go here, so harpoon that. We can use a hash map. Let's do that. Let's use a hash map. Anyway, so he makes a hash map and then he loops through all the methods, defines a function type and puts that in there, and then he makes the class. With those methods and assigns it to the environment. So we're gonna do something quite like that. We are going to say let mutable methods equal hash map new, and for method methods, and I didn't mean to do that. Method and methods. Let's make a function. Actually, what? That's a bit annoying. This is an error. Because it needs a type annotation. Yeah, whatever. Let's just comment it out. Okay. Let me go back to expression. Literal value, so the instance, or rather the anonymous function. How does that look? Well, I guess maybe we do something like we interpret the method. I guess that works. Let's jump forward and yeah, it's just a statement, but should be a function statement. And let's then say methods.insert method name. Let's try that. Why doesn't it? And what is the problem here? Unused variable. But it's like clearly used. Anyway, let's do that. What exactly? Here's the problem here. Oops, undo. Okay, now I see the problem. Methods map, let's call it. Methods map, and actually that's not. Methods map, it's not supposed to be like that. Great. And there shouldn't be a 2. Still is complaining. Vector of box of statements, sure. And this is what? Box statement. And because we have to write before it realizes that I changed something. Fair enough. Expect a struct vector of statements, so I guess that is not what I wanted. I guess we do this. No field name on it, that's fine. I guess maybe let me go back to the parser. Okay, so we can not do that. We can do if let. This is a bit annoying, but like function name. What else does it have? A body. We don't care. Arguments. We don't care. now we can do this. And if it's not, if there for some reason in the methods there's something that's not a function, we can just panic. Something. This is a horrible error message, but I'll write it anyway. And why doesn't it like this? Do we need to do this? I think yes. Still there's something. Because it's not called arguments, it's called params. Is that it? Params body statement function. So this one we have to dereference maybe. Huh. That's not nice. Anyway, let's delete that one. Should be good. What's it complaining of here? Cannot move out of. Damn. Okay, so we could get rid of the errors by adding a reference here, which I'm pretty sure is not the way to do it. What is this thing? It's a reference to a box. So I feel like it should already be kind of like a reference, but it's not. Maybe if we call sref. That's a little bit better. So anyway, now we do this. Now when we make the class, we should say methods is methods map. And to get that to work, we need to go in here and we have to say that this is a hash map from string to literal value. And now, no, that's not what I wanted. Jumping around a bit here. I wanted to say, yes, exactly. Can I find type hash map? Fair enough. Use std collections hash map. Great. And this one has to be unwrapped. Now we should be good. Expected type. Oh. Oh. Right, because that's interesting. Actually, I really want, so this is a list of statements, but actually I think it should be expressions, because that would allow me to say something like method.evaluate on the environment. Well, self dot clone dot self dot environment, and yeah, I think that's what I want. But now the problem is it doesn't know about that, so we have to go into the parser, and yeah, this is giving statements, which is not what we want. So I don't know if this is a bit of a hack, but we should have the code exactly. The function expression. So let's go back up to the class declaration. This one. Right. So if we don't have a right brace, then we're basically inside the body, and I'm not using this for anything, but I think I want a function expression instead, and we don't need this, I think. No, that was wrong. Forward, forward, forward. So when I go forward, it also selects the parentheses. I'm not, okay, so I can do this. Okay, so we get a function expression, and that is just, that's exactly going to be an expression. We want to put that in here in the methods. I don't think we need to box it, so I'm going to delete that. But then we need to go into the statements and change what it means to be a class. It's not this, it is this. And apparently it's boxed in other cases, so no, that's just the I don't know if this is a, maybe this is a bit dangerous. I'm gonna keep it for now. Let's undo. Let's go back in the interpreter. So we cannot evaluate it like this. But we can. Actually, it's a bit, our logs function equivalent is this callable, right? We have an anonymous function, we have, that's about it. So maybe, because what I'm worried about is how we handle like this keyword. Okay, let's just try it. Let's try to say we want an expression. Get rid of that thing. Oops, undo. Then let's go into the statement and say that this is no longer a statement, it is a vector of expressions. Let's double check. Now this should be fine. What is the complaint here? Still thinks it is something like that. This thing we can remove. Oops. And it doesn't like that because the method is supposed to be a function. It's supposed to be an expression, and also actually an anonymous function. So let's encode that. We have an undeclared type, so let's wait a second. We have it here. Okay, ID paren arguments. ID paren arguments. And the body. But I guess this is mostly a sanity check. Don't really need it. It's getting a bit of a long line. Anyway, so we check that it's a function, we evaluate it, we insert it, and then we add it here. So let's just check that it actually, it did not. Because here in class declaration we box things which we don't need to do, and let's add an m back. Okay. Okay, let's see. I also harpooned my config for the language server protocol here. So now I should be able to do something like to go to the next error. Amazing. That is very good. So no methods. Great. Go to the next error. This is pretty nice. Go to the next error. Something. Sorry, methods. Not that, but this one. And next error. Methods. One, nothing more here. Let's then run cargo check. There is something in the resolver. Interesting. So we can only resolve statements. I didn't think about that. Let's check this one. It takes a vector of tokens, but I think this is a vector of tokens and a vector of statements. Yes. So we can call this thing. If I go back up, instead of this, we can say, again, that was wrong. I have to say VE. Then we can say resolve method. Now it should complain that that doesn't exist, but that is fine. Let's copy, paste all of this, and we'll say VED, resolve method, and it's not gonna be a statement. It's gonna be a, let's call it method. And again, it's gonna be not a statement, but an expression. Don't really need the function type, but I will just keep it. And we're not gonna let me go into the interpreter. Let me grab this, go back, and put an empty line there, put all of this copied stuff, and not that, but this. Now it's still complaining, but it's fine. Okay, if it is an anonymous function, then what is the name? Actually, let me go back here. What is this type? Okay, it is an expression. And this is also a vector of expressions, which somehow doesn't make sense to me. Yeah, I guess, I mean, it kind of has to be if that's a bit annoying. I kind of wish we could use this, but it makes, why is it that makes the interpreter so hard to write? It's because we cannot turn a statement into a function like he does, but maybe that's just what we have to write then. So I think I need to take a break here because I'm just like rewriting code over and over. So I think this will be the end of this video, and I will see you in the next one.